Hello, ViewSource. I always do this. One day I'm going to write a talk that doesn't involve any JavaScript or any hardware or any audio. And I'm always like, yeah, but that would be really boring, wouldn't it? My name's Ruth. I'm going to sort of cut out that really long intro because I do have a lot to get through. I've only got half an hour. And I did a run through in my hotel room, and I was like, oh, my goodness me, this is like an hour. So I'm going to talk very, very fast. I apologize in advance. I hope, if you're not a native speaker, that I don't talk too fast for you. I have captions, so that is actually helpful. Thank you very much, Sarah. Great. If you do need to find me, I'm at Rumira on the internet, so you can find me on GitHub, CodePen, Twitter, at Rumira, right? So you can ask me any questions on there. You can find all my code examples, everything on there. They are going to get tweeted out via the account as I go, so it's all good. Now, the reason that I have so much to get through is I'm here to talk to you about web audio, right? That's this specification. This is me scrolling through the specification without stopping, sped up, 2.5 times. It took me 8 minutes. I think it's the longest web API specification that we have. It's very intimidating, and it is very long. I'm going to try and break it down for you. Big shout out here. This is going to happen throughout the talk. If you do want to look anything up that I talk about, shout out to MDN Docs. It's a little bit more digestible, right? This is me scrolling through in real time. I'm having a good time. It takes me through everything that I need to know. This is great. I kind of want to get it to the end because it's nice. You're like, yep, super chill, yep. I mean, it's still quite long. It's still quite a hefty specification. Like, got some workers in there. We'll get to that. That's cool. Some example code. MDN's great, isn't it? I'm going to shout it out throughout this whole talk. It's going to be brilliant. Was this article helpful? Yes, it was. Thank you very much, Mozilla. There is this barrier of entry with audio, and it's not just a specification like this, and it is pretty hard if you don't come from a musical background. When I talk to developers about audio, I can see their faces. Their brains are sort of doing this, right? This is as loud as I get. This is a real website. This is CameronsWorld.net. It is relatively new, but this is what we think about. We think about that in 1998 background sound tag. And you're like, yeah, that's not even a tag. Like, that's not an HTML element anymore. It is depreciated. We don't have to build things that look like that anymore. The web has moved on. And then we do have the modern day equivalent. You know, you're reading an article, you're a young mum, you want to make $9 grand a month, great. And then this video starts playing right on the right, and you're like, I don't want to hear that. You can't hear it because the sound's actually really low on my laptop at the moment. Do an audio talk where your sound's low. Definitely the way to go. There are some policies in place that are coming out now to stop this auto-playing when you do load on websites. I'm going to talk about that as well. So bearing these things in mind, we don't have background sound. We're not going to do horrible things like make it load like autoplay when we make websites. I think that we can create better experiences for our users. This is my favorite. This is a project from Norway. It's called Future Library. They're growing a forest. They're having a tree for every single year, and they're getting an author to write a book for every single tree that they grow. And there's this sort of ambient background noise as if you're in a forest. This isn't just a website where you're going to read some content. This is an experience. And it takes you through all the books, and it takes you through the authors. And it's really, really lovely. And that sound is not obtrusive. It's not sort of aggressive. It's just a really nice experience. This is a project called 86.5 Years. It's a story website about the musings of an 86.5-year-old man. Again, it's just a lovely ambient sound that I'm listening to, which adds to the whole experience. It's not detracting from it. It's not detracting from you experiencing the website. There is a place for audio here. The web is connectivity, it's information, it's education. Ableton, they're a company that make musical instrument hardware and software for doing music on the OS. They built learningmusic.ableton.com. And sure, they are heavily invested in music, but this takes you through sort of the beginnings of electronic music and beats and synths and drums and things like that. And they wouldn't have been able to do this if it hadn't been for the Web Audio API. It has given us the power to do things like education, which I think is brilliant. how do we go about creating experiences like this? I have got about 20 minutes, all right? It's going to be a whirlwind tour. I hope you're ready. What I'm going to start with is a little lesson about digital audio. I'm hoping, oh, please let this slide work. Okay, yes. You've probably all seen a graph that looks like this, right? This is depicting a sound wave. We're probably all well aware that sound travels through materials in waves, just like light does. As I'm talking to you, that sound is going through the air, it's hitting your eardrum, you're picking up on it, and you're hearing it. That is how sound works. This is how we depict it. This is actually a very pure wave. This is a sine wave. It sounds a little bit like as you can hear, there's no sort of noise apart from my lovely little crackle at the end there. And this is easy to generate electronically. What I'm speaking to you doesn't look like this. What I'm speaking to you, although my voice is lovely and beautiful, it doesn't look like this. It looks like more of a jaggedy wave, right? So what do we have? We have this sort of wave over time. That's your horizontal axis. And we've got this sort of amplitude value on the y-axis, the up and down. And all we want to do with digital is we want to record the y-axis at any given time, right? This is where we start to talk about sample rates. All we want to do is record that number at certain intervals so that when we play it back, we can recreate that wave. A normal sample rate would be something like 44.1 kilohertz. That's 44,100 numbers per second that we are recording. That's a lot of numbers. But as a simplified version, that's all digital audio really is. It's all it boils down to. It's just a file of numbers that then just gets recreated and played back. As soon as you sort of get that, everything else becomes a little bit easier because all we're doing is manipulating those numbers when we do stuff with audio. Okay, simplified digital audio lesson over, right? Now we can start to write some code. Web Audio API, how do we do that? Loads of code. We're instigating a context, right? That we only need to do this once per application. So in my talk, I'm just going to do it once. And I'm just doing new audio context. This is giving me all the power of the Web Audio API. I now have all the methods and all the properties that I'm going to need to be able to create some audio, to load some audio, to manipulate that audio. I'll take you through some of the stuff that it can do. We need some sound. We've got our Web Audio API. We need some sound. There's plenty of ways to do this with the Web Audio API. I'm going to take you through 3 ways to load it. You can grab it from the DOM. If you have a video or audio element within your DOM, you can just grab the audio source from that. And your audio API is then taking over that audio source. So all the manipulation that you can do with the Web Audio API is going to go through that. The HTML media element, that video or audio element, is going to stay the same. You still get the power, so you still get all the events on that element, but the audio is going to go through the Web Audio API. You can stream it. So you can grab the sound from your camera or the microphone on your device, and you can stream it into the Web Audio API. There's a method to do that. That's pretty cool. Or you can just go and get a file. HTTP request a file. Now, this is a little bit more complicated because audio files usually are compressed. So you've got things like MP3s, WAVs, FLAC, things like that. You have to make it into a format so the Web Audio API can understand it. So what we're doing is we're going to get a file here. We're going to actually decode that data into a buffer for the audio API so the audio API can read those numbers, right? Buffers are important. We're going to get back to them later, but that's what we're doing. In any of these instances, we're just going to give the audio API some numbers. We've got some sound, but we still haven't been able to play that sound. We're only just fetching the source here. To be able to actually play it, we have to connect it to a destination and play it. This is where the audio API becomes just a little bit more, like you have to do quite a lot of stuff for very little sometimes. So here I'm connecting what we had before. So any of these can be our source. And I'm connecting that to the destination, the context.destination. By default, this is your speakers. This can be other things. You can write it to file. You can stream it, do some WebRTC stuff. But by default, I'm just going to connect it to my speakers. Then I'm going to start it. Source.start. That's the method. Quite a lot of stuff just to get some sound playing, but there's some cool stuff we get the Web Audio API I'll get to. This goes a little something like this. That's all I've done. I've gone to get a file, decoded it into a buffer, connected it to my speakers, and now I'm starting it. That's it. Great. 10 minutes down. I'm going to mention a little bit, so you can't see that too clearly, a little bit about audio graph and nodes, because we talk about these a lot in audio, especially when we're working with the Web Audio API. You're going to hear those terms. Nodes are that source that we had and the destination. They're both nodes. We've got a source node, we've got a destination node. And we're going to look at some modification nodes in a minute. They're going to sit in the middle here. They're all just the things that do stuff. I'm going to get something. I'm going to pass it over here. I'm going to filter it. I'm going to change the volume. They're all your nodes. What we tend to do is this tends to get very complicated very quickly because we tend to do a lot of stuff with audio. And so it's really nice to draw it out. So you draw a little box for each node, and then you link them all together so you know which things are modificating which sounds. So we draw an audio graph. So this is a really, really simple audio graph. We've got a source node. It's connected to the destination node. These get a lot more complicated. This is a very simple example. One piece of functionality that you might need as a developer on a website, and I know that devices have this functionality, but it's always nice to keep it within the interface itself, is mute functionality or just volume control, right? Because your volume might be too high for them. They might want to turn it up. You never know. The two examples I showed earlier, there was actually no mute on the AE 6.5 years, which I do think is a bad UX. Like, I can turn it down on my laptop, but I think it is nice to keep yourself in that experience. The way that we do that is we create another node in the Web Audio API. So we create a gain node. The gain node is going to control the volume, right? And how we do that is we create it, and we can set the value of the gain. 0 is unmuted, 1 is keep it at the volume it is, 2 is double the volume, right? Pretty simple stuff, and that's all I'm doing here. But we do have to remember I've created the gain node. I set the value of what I want it to be. Here it's 0 because I don't want any sound. But I've had to connect it through my audio graph, right? So the source is now connected to the gain, which is now connected to the destination. Cool. So we've got some mute functionality. Do that all day. And our audio graph looks a little bit like this. We've got a source, we've got a gain node, and we've got our destination. Web Audio Basics. If that was all a little bit too much, or you want to try it, there is a tutorial on MDN Docs. Yeah, someone wrote that. It takes you through everything that I just went through. It's purely coincidental that I've come here to talk about it, and I've just happened to have written a tutorial. It takes you through everything that I've just said. So all the beginnings to instigate the Web Audio API, doing some volume control. You can even do some stereo panning, so you can actually get this to pan left and right to your speakers, because that's another node that we have with the Web Audio API. There's a whole bunch of modification nodes. I don't have time to take you through all of them, but if you go and have a look at these tutorials and you go and have a look at the documentation, now that you can understand that concept, you'll probably be able to get a grasp on all the different ones that we have. New thing, just a shout out. I want to talk about the autoplay policy, just briefly here. There's a lot of sort of random information about the autoplay policy. It's all to do with when you land on a website not having videos autoplay for you, not having like loud music autoplay for you. I'm sure at some point it's probably going to start including like flashy animations not autoplaying, because that can be detrimental for users as well. As far as the Web Audio API is concerned, the bit that we're interested in, I really wish there was a proper technical specification for the autoplay policy, but there isn't. Create or resume a context from inside a user gesture. So the context that we have, this web audio context, comes with a state, and when we start it, it should be running so that we can play things. But if we start it outside of a user gesture, so a user hasn't had any interaction, it will actually start suspended, so you can't actually play anything. So you can't actually do like load something and have something play. Right? That's the idea. So if you want audio to play, you have to have some sort of user interaction with your page before the audio will play. So a good check is, say we've just got a click event going on, check the audio context state. If it's suspended, then change it to running by doing audio context.resume. And that's all you need to do just to go over the autoplay policy. It's probably going to be in all browsers soon. And it just means that if you are working with the Web Audio API and things aren't playing, it might have something to do with that. You need a user gesture first. Other places that you might need audio, other places that are getting very popular at the moment, I kind of lumped these all in together. Things like WebGL, gaming, XR, that is gaining in popularity. Now, the reason I've lumped these all together is because because we call it something in audio, we call it spatialisation. Now, this is the idea that audio actually is directional and in space, right? So if you can think about it like this, you are listening to me speak, whether you want to or not. It doesn't really work very well because I am going through a mic, so you are hearing me through speakers. But if I wasn't, you would hear me from here. And if I moved over here, where I am, where the audio source is, has changed. If I was above you, you would hear me from above you. And as a human, you're pretty good at this, right? Your ears are good at knowing where sounds are around you. You can probably cross the road closing your eyes, actually, if you think about it. Don't do that. But, like, you probably are quite good at this. And this is what this does. We have a panner node in the Web Audio API. And this allows you to do all of that audio spatialization. It is quite complicated. You can see it here. We have to set a listener. So if you're my listener audience, I have to set where you are and which way you are facing. Then I have to do the same thing with the sound source, but it does get quite complicated. I have to set where I am, which way I'm facing. I can do movements. You can do things like cones. If you think of sound like light, and you have like spotlights have cones, so does sound. So you can have omnidirectional sound that goes all the way around, or you can have sound that's directional. You can set all of that with this one node, right? Pretty complicated. I won't go through all of them. New thing, you might notice here, I've got const panner equal new panner node. This is a new thing. This is a class-based way of instigating nodes. Before, when we were creating our gain node, we just did context.createGain, and we had a gain node. That's the factory way of doing it. That's how we've always done it. We now have, you can use both. You can use either or, it doesn't matter. But this is sort of a little bit nicer, a little bit more extendable, especially when we've got all of these properties to set. It actually looks a little bit better. So new thing, class-based syntax, nice. Don't worry if you didn't get it, but if you are interested in spatialization, because it is really interesting, but very in-depth, there's a tutorial for that on MDN hooks. Yes. There's a little boombox here. I'm wondering if I can actually play with it without breaking my entire... Don't write things in JavaScript, everybody. So yeah, you can move this around and it'll play, and you can zoom in and out, and you can hear the audio change whilst you do it. So there's an article that takes you through everything and all the different parts. And it's not just gaming and crazy 3D things as well. This does appear on websites. Any Harry Potter, I feel like I've there we go, unactivated everything. There we go. Any Harry Potter fans might have seen the Hogwarts WebGL website. They used a lot of sound spatialization in there because they had things flying overhead and sounds coming from like way over there, and it was all kind of spooky. It's a really nice example of this spatialization. I would recommend, though, if you do want to do it, I don't usually recommend this, it's quite heavy on the maths. 3JS and A-Frame, the WebGL Frame libraries, they do harness this. So you can just use what they've baked in. Music, right? So any musicians out there, I kind of had to keep this in here. This is Blockdust, built by Luke Twyman, Luke Phillips, and Edward Silverton in Brighton. This is actually an online synthesizer, right? It is, if you're not familiar with synths and drum machines and sequencers and all this crazy stuff that we do with electronic instruments, it is a little bit confusing, but it is really nice to play with. And they've kind of reinvented the interface a little bit because we're so used to those things being hardware. The wonderful thing about the web is that it can actually be software and you can do whatever you want. I mean, look how pretty it is. If nothing else, you can appreciate that, right? The Web Audio API obviously gives you all the abilities to sort of make noises and make instruments and do all of this. It's just probably what you've seen a lot of. So I will cover this because I've got another 5 minutes. We can make sounds with the Web Audio API. That sine wave that you saw earlier, that's pretty easy to generate electronically. We have an oscillator node that's going to generate the sound. You can create like the 4 basic types of waves. You've got the sine wave, which is curvy. You've got a square wave, which is like this square, triangle, and sawtooth. The reason you've got those 4 is because they're easy to generate electronically. You can actually set your own wave. So you can actually create what we call a wavetable, which ends up being like 4,000 lines of JavaScript. It's kind of crazy. But you can actually set your sort of measurements of your own wave, and you could pop that in the oscillator as well. These values that we set on these nodes, so our gain node, we had a value from like 0 or 1 or 2 or whatever we want. It's the same with the oscillator. When we create an oscillator, we can change its like tone, its frequency, so we can make it low or we can make it high. these values that we can set, we call them of type audio param. Now, these audio parameter types come with a whole bunch of stuff unto themselves as well. Like, this API just keeps on going. So what I'm doing here, just quickly, this is where I kind of lose everybody. The frequency, I'm starting it, you heard the sine wave earlier, I'm starting it there and I'm just dropping it off low pretty quickly in about a second, but I'm doing it in a nice curved fashion. The same with the gain, I'm starting it at 1 and I'm just going to drop it off in a nice curved fashion. And if I do that, got a laser, yeah, in like that much code. But obviously you do need to know what you're doing. I'm just going to do that for you. Yeah. So there's like, you can just go mad with this stuff, which people do. Remember we were talking about buffers and how we take that file and we put the data and we make it readable by the audio API? You can create an empty one of these and fill it with your own numbers. That's also pretty cool, because if we fill like this empty container with random numbers, we're probably going to get white noise. Everybody's like, yeah, I know that is random numbers. Be aware of this one. It doesn't sound great. Told ya. We can make that sound better. So that is just me creating an empty container, putting in random numbers. That's made some white noise. We do have some more nodes. We have some more modification nodes to make that help. We've got some filters. We can shape it. We can put some reverb on it. That's going to put an echo on it. We could use any of those. I'm actually going to filter out some of those frequencies just to make it sound like less hissy and less tinny. That's a little bit nicer. We actually call that brown noise. That is actually true fact. Yeah, if you learned nothing else today, I've learned what brown noise is. It's white noise without the hiss. So that's great. And if I did what I did earlier, where I dropped off that frequency and I dropped off that gain, there we go, right. Got a snare, just like that. That just came from the white noise, right? We do have a new filter in the Web Audio API. It's the IIR filter. I really don't have time to go into this. This is like quite sort of low-level signal processing. Bi-quad filter, which is what I use to take those high frequencies off of that white noise. I was basically just filtering off those high frequencies. That's why we call it a filter. Is a type of IIR. IIR is like one level down, where you have to set up all the parameters yourself. It is quite involved, but if you're into it, it's really cool to play with. And if you are interested, somebody wrote an article about that. It's on MDN Docs. Go and check it out. I want you to go read this one, because this one was really hard to write, because it's all like polynomial maths and this and that, and you're like, oh, coefficients. That one was difficult. Okay, timing is important with audio. If you go out of time and you're playing live in a band, everybody knows it. Imagine the drummer going out of time. Timing's important. We have a property on the context. It's called current time. It works on system hardware. It doesn't work on JavaScript timing functions. They're a bit of a nightmare. They don't stay in time because they're working with lots of other stuff going on. So this keeps things in time. Again, I don't have all the time in the world to go into it in depth. There's an article by Chris Wilson called A Tale of Two Clocks. I recommend you reading that if you do want to go through all the different JavaScript timing functions and how you can incorporate context.current time and have a nice time with it, pun intended. So we can actually, like the hi-hat was made very similarly to the snare. I've just like made the frequency a little bit higher. And I'm just using that current time to sort of loop over it and play it. I would say that was pretty accurate, right? It's just giving me a second value back off of my hardware, and I can hook into that and I can do my timing. Worth a mention, new things, audio worklets. Really glad that we had some discussion about workers, because I don't have to tell you what a worker is. This is like the space station with a recording studio already on it, right? Like, this is the thread that has been taken away, and like, you have pretty much a lot of what the Web Audio API gives you, but you're doing it like not on this main thread, which is great, because we had this idea when it first, like the spec first came out 2011, 2012, and we've just been waiting. And it came out last year, and everybody's really, really excited, because it's taken away a lot of things like latency issues when you are just working directly in that browser. You still do have a lot of problems with all that processing that's going on. A little snippet of code. If you are interested in more of the instrumental kind of stuff I just went through, because I did just go over it very, very briefly, and I'm sorry that I didn't have a little bit more time for it, there's a tutorial about that on MDN Talks. Someone wrote it. You can build a little step sequencer. It's actually pretty cool. So this is a little thing that goes through, and you can create all the different sounds, so you can actually get to create a drum and all the rest of it. And it will take you through all the more advanced techniques of the Web Audio API and all the different nodes that you have. Fist bump. Woo, 20 minutes, Web Audio API. Well done, everybody. I don't think I've ever done it that quickly. Usually it's about 40 minutes. So yeah, well done. I'm happy. Now I have to include this in here. Okay, so it's giving me a nod. MIDI, right? Because you can't talk about audio without talking about MIDI. You can, but I'm not going to. The reason is because I want to re-educate everybody. What we saw, this is not MIDI. I know that it sounds like bleepy, like that 80s kind of noise. Those noises that you are hearing, that is audio. All those noises you hear, you do that with the Web Audio API. The Web MIDI API is a separate API, and it's just a digital protocol, right? It is just messages being sent around instruments. It sort of came about because of the rise of popularity of electronic instruments in the 70s. The first specification came out in 1983, and it is all to do with these instruments being able to talk to each other. So all it is you press, you're playing a keyboard, and it is just sending messages so that other instruments know when that keyboard is playing, right? A little thing to note is that the keyboard is an instrument. It's a MIDI-enabled instrument. If you are playing a keyboard, like a piano, not the keyboard on your laptop, that has onboard audio. So that is an instrument, and standalone it will play. Most keyboards these days are MIDI enabled, so they will also send these MIDI messages as well. So if you plug it into your computer, you can pick up on those MIDI messages. These are MIDI controllers. These are, by sort of roughly speaking, a little bit cheaper because they don't have that onboard audio. And all they are is just a box of buttons that send MIDI messages. I have one right here. It's just a box of buttons that sends me messages. So I can plug that into my computer, and in my browser, I can pick up on those messages, right? There's a little bit of code there. All I'm doing is just requesting access to it and then listening for any button presses, right? And then I'm going to do some stuff. Now, this is where we go, it may or may not work. It's working, good. So as I'm pressing my buttons, this is basically, that's the next demo. Thanks, Talk. It's not going to... Okay. Don't do live demos on stage with JavaScript. Just FYI. This is the sort of data that you get back, right? And it's all to do with which sort of button you're pressing, which controller that you have. And sometimes you have velocity as well, so the harder you press, you get a different value, which can be really, really interesting. And you can do all sorts of stuff with this. As you heard, we can take the noises that we had earlier, which have now kind of stopped. We got, I think they have. Oh, it's just really, really, really quiet. I don't know why. So I can just press the buttons and kick off those sounds. That's the idea. Great demo, Ruth. Yeah, thanks. Thank you very much. Cheers. Anybody who wants to have a play, we have a play later. I've got it here. God forbid that you'd actually create a website that used one of these to control the website, right? Yeah, that happened. The artist Marion from France, We Make Awesome, actually created this website. You can actually plug one of these in, actually, one of these launch pads. That's what this one is called. There's lots and lots of different controllers out there that you can get. It works without it, so you can just go and you can just click on the interface and it will play you sounds. Or you can plug one of these in and you can actually play it using one of these, which I think is really interesting. Novation, they have a synthesizer where they update the synthesizer via a web app. Right? So you can put all your samples and you can use this piece of software via plugging in your synth into your computer. So this is harnessing Web Audio and Web MIDI a lot. So this is actual real stuff that people are actually doing. Actual companies are using this in real life. You can also, just change text size, like Laurie Cape did. Like, why not? I mean, this is just picking up on events. I think it's an amazing way to hardware enable your browser, which I'm quite excited about because that's basically the next talk. Or just because I wanted to, it's tiny, weeny, just wanted to keep that visual in there. I can just change my visuals by pressing buttons, which is what I do. I know that some of these demos are not necessarily the things that you're going to go and start developing on Monday morning, but I do hope that I've given you an overview of how maybe audio is something that we can start to think about on the web. One of my friends said recently that the internet and digital is like being in a mall. It's like being in a shopping center. Everything's adverts and everything's loud and bright lights and everybody's trying to sell us something. And we actually need some more parks and we need some more oceans and we need some more forests. And the sound that comes with that, that's very different and it's actually very nice. So please go forth, make noise. Thank you very much for letting me talk to you about the Audio API, and I did it half an hour.